In this video, we're going to continue with section 2.5 in marginal cost and marginal revenue, but this time we're going to see what we can say if we're given the graph of the cost and the revenue. For example, what can we say about the profit of the business who has these graphs as their cost and revenue function? Okay, so what you'll notice here is that R is just a line, so that means the marginal revenue is going to be constant. Let's see what that constant is. So it's a line, so all we need to know is the difference in two y values and divided by the difference of two x values. So we have here, let's compute this, 200, that's a difference in y's, over, let's say, 25. So the marginal revenue would be equal to 200 divided by 25, that's just 8. Okay, now let's look at the cost function. You see this is not a line, and so the marginal cost is not going to be constant. So we're going to have to compute the marginal cost at certain points. Let's look at 50, for example. So right here. Let's draw the tangent line. So right there at 50. Okay, so the slope of this line is precisely the marginal cost. So the slope of this yellow line is the marginal cost at 50. And notice how this yellow line, it's not as steep as the slope, it's not as steep as the blue line. And so in particular, the yellow line must have smaller slope than the blue one. And so the blue slope, which is 8, must be larger than the marginal cost, which is the slope of the yellow line, at 50 items. So the marginal cost at 50 is smaller than 8, or in particular smaller than the marginal revenue. Let's look at another point. Let's look, for example, at 90. So right around here. Okay, so and it intersects right here, for instance, and let's draw that corresponding point for tangent line at 50. Okay, so if we look at this purple line now, you'll see that first of all it's steeper than the yellow line. So the marginal cost here is larger than the marginal cost at 90 is larger than the marginal cost at 50, but it's also steeper than the blue line. And so the marginal cost at 90 this time is larger than the marginal revenue, which is 8. So we know at least it's larger than 8. Okay, so let's see, what do these two facts imply about the profit? So remember, profit, that's equal to revenue minus cost. So if we take the derivative of this equation, we'll get P prime equals R prime minus C prime. But what is that? P prime is just the marginal profit, and R prime, that's just the marginal revenue, and C prime is just the marginal cost. So depending on when marginal cost or marginal revenue is bigger or smaller, corresponds to whether the marginal profit is positive or negative. So for Q equals 50, for example, we know for a fact that the marginal profit is larger than 0. Why? Because the marginal revenue is larger than the marginal cost. And this automatically tells you that the profit must be increasing exactly at that point. Okay? How about at Q equals 90? This time the marginal profit is negative. and that's simply because the marginal cost is larger than the marginal revenue this time. I mean at 90. So this implies that at that point the profit is decreasing. Okay, so how could one interpret this information? If the profit's increasing, the profit's increasing, the profit's decreasing at 50 and at 90 respectively. So consider this scenario, or consider this question. Should this business produce a 50th item? Okay. Well, at the 50th item, you know that the marginal profit is positive, and so that your profit should be increasing at that point. So the answer is yes. The business should produce the 50th item because it's going to give them more profit. It's just going to increase their profit. On the other hand, if you go to Q equals 90, you see that the marginal profit is negative. So actually making the 90th item is going to decrease their profit. And so you wouldn't want, if the business had made 89 items, you would advise it not to make a 90th one. Okay, so that's one example of how to interpret or apply this kind of information. What's another thing you could say? Well, let's see here. If the marginal profit's greater than 0, you know what happens. If the marginal profit's less than 0, you know what happens. What happens when the marginal profit is exactly 0? When is that going to happen? That's going to happen exactly when marginal revenue is equal to the marginal cost. And you see, how are we going to determine that from the graph? Well, if you look here, the slopes seem to be increasing. I mean, the marginal costs seem to be increasing the more items you produce. I'll get to that point in a minute. But you see it's increasing from, let's say here, below 8 to above 8. That means somewhere in between it had to be exactly 8. So let's make it green. Make this line green, and we'll see that, well, we can do this a little better. Here we are. You see that the green line now, so this is the tangent line at, let's say, it's around 75, rough, give or take. Okay? This green line has exactly the same slope as the blue line. And so in other words, the marginal revenue is equal to the marginal cost there. And so we know the marginal cost at 75 is actually equal now to the marginal revenue, which is 8. Well, notice how I'm not putting a value to evaluate the marginal revenue at, because we know it's just a constant. But the point is, at 75 items, the marginal cost is exactly equal to the marginal revenue. What's the interpretation of that? So what does that mean? So this is second fact. So we know that before 75, so around 50, the marginal profit is positive. That means we're making profit. But then after 75, for example at 90, the marginal profit is negative. That must mean that at 75, where the marginal profit is exactly 0, we must have reached a peak, because it has to go up before 75 and then down after 75. So that's also a special point. This implies actually that the profit has a peak here. Okay? And I'm referring to the graph of the profit function. Alright, so that's yet another thing we can glean from knowing the marginal cost and the marginal revenue. And the third thing that that would be interesting to point out is returning to, again, the shape of C, of the function, of the cost function. You see it's a concave up function. It's not a line. It has some curve in it, and it's concave up. What does that mean? Well, let's see. In terms of marginal cost, let's see. So at the yellow line at Q equals 50, we have a slope that's less than 8. At Q equals 75, the slope is exactly 8. And then at Q equals 90, it's larger than 8. And so concave up means that the marginal cost is increasing. So concave up, so C being concave up, means that the marginal cost is increasing. Now, what's an interpretation of the marginal cost being increasing? It means that the more items you produce, the more it'll cost you to produce that item. Okay? So to try and put it another way, the more it costs more to produce more items, or each particular item. Okay? The cost of each particular item you make will cost more and more. That's what it means. Okay? So these are three nice things you can get just by looking at marginal cost and marginal revenue. You can say a lot of things about the profit. And concavity also says something special about the business itself.